Excellent. Thank you. Can you guys hear me in the back there? Good? Yeah, back row? All right. So thank you. So my name is Dmitry Baev. I'm a solution architect with MongoDB, previously known as 10gen. And my job as a solution architect is to work with customers and users alike to help them build the next generation of applications on top of Mongo, right? And a lot of these applications were, not possible to build some 2 or 3 years ago due to a number of different reasons. And I'll talk about how Mongo really enables you to build these kind of new type, new edge, innovative applications. So with this talk, we only have 40 minutes, so I won't be able to get into all the nitty-gritty details of Mongo, but I really want to kind of put together how it all fits together. So we had some really great talks today about Angular, about Express, about Node. Kevin talked here about Mongo. I really tried to put this all together and show you a demo of the mean stack application that has everything kind of rolled into one place. So why Mongo? Actually, before I get into this, can I get a show of hands? How many of you have seen, used, or heard of Mongo before? Okay, wow. So it's like 90%. How about relational databases? Any kind of SQL relational database? Okay, pretty much 100%, I would assume, right? Okay, excellent, good. So a lot of the concepts that I'm going to be talking about, there is a correlation between the NoSQL databases such as Mongo and any kind of relational databases. So I will draw those parallels for you. So why Mongo, right? I mean, what are the applications that you couldn't do before that are now possible today with a NoSQL database such as Mongo? So for once, if we go and see any kind of a larger enterprise type of customer, right? They may have all these legacy systems with rigid schemas. So if you have a relational database, right, you have a schema that defines, how your financial system works, how your HR system works, how your payroll department is structured. And if you're trying to aggregate this data together, kind of like a data hub scenario where you want to bring everything together, give you a kind of like a single view of your customer or a single view of your employee, that is really, really hard to do with a relational database just because those schemas are so rigid, right? And you have to spend, months and years into building a master data management type of solution to really be able to pull this all together. So this is one where Mongo really shines, and that is the flexible schema design. It's really simple, really quick and easy. Mongo doesn't really care how your documents are structured. But I definitely want to make a point that it is important that you have somewhat of a defined schema, right? JSON document model. Again, this really takes away the abstraction that you had to do with any kind of relational database where you would specifically construct an ORM layer, right? The object relational mapping layer. So because your entities, your objects in the application layer are vastly different from how you will structure how your data is structured with a relational type of solution, right? So you've got tables and columns, and this is very different from objects in any kind of programming language, whether it's Java, JavaScript, C#, whatever it is. And by using JSON document models, we're really making it easy for you to construct, get your documents from the database, present them in your application layer, and then store them back using the same type of JSON notation. And a lot of other great features which I'm going to go through as we talk. So I hope the terminology is fairly clear, but just to make sure we make this alignment. Tables in the relational databases map to collections within Mongo. Rows, so a row of a table maps to a document, and we'll talk about document structure in a second. We've got indexes. We do not have joins. So this is one of those big things, right? A lot of people would just throw up their hands and say, hey, you got no joins, you can't be a database, right? It's not a valid database if it doesn't have joins. But that's not completely true, because in many cases, there is overwhelming number of applications where you can get away from doing joins. There are actual benefits of not doing joins by doing those embedded documents. And we do have references, so if you do have to have a relational, if you want to have a relationship via a foreign key, the way you would do it with a relational database, you can still do it in Mongo using references between different documents. All right, so what is the main difference, right? If I just look at it from a very high level, if you talk about a relational database, which have been designed some 30 or 40 years ago, the relational database really focused on data storage, right? So for any particular system, My goal as a data architect was to design a data store, database, right, which could store, all this massive data, right? I can just put it in there, and any kind of applications you want to build, I will have a solution for you because I'm going to normalize my data. I'm going to create 1,000 tables, and you can query and you can join them via SQL and throw any applications on top of this data schema that I designed for you, and you have a solution, right? I mean, it's all great, but the downside is that it takes a long time to build something like this together. And if you are doing a system which has more than 10 or 20 tables, I've seen customers building on top of relational schemas that have thousands of tables, it becomes pretty unmanageable fairly quick. In Mongo, right, with the NoSQL database where it's all document-oriented, we take a different approach, right? We focus on the data use. So rather than giving you a solution and saying, hey, and the analogy that I like to make is kind of like an encyclopedia. So if you're in the relational land, you've got these massive encyclopedia that has thousands and thousands of terms and things you can find in there, and I basically say, hey, there you go, just go look for whatever you need. In Mongo, right, it's very different. In Mongo, before I give you all this stuff, my first question to you is, well, what are you really trying to find there? Give me the questions that you want answers to, right? And I will give that to you. So rather than trying to design a schema that is an answer for everything, we build a schema that really provides the questions that are needed to this particular application or a domain or a developer, right? So a very different ideology, very different approach to how data is being produced and consumed in Mongo world versus a relational world. All right, so let's take a quick look of it. Again, very high level. What is the difference between the relational and the document-oriented view? So when we talk about document-oriented view, I'm not talking about Word documents, PDF documents, and so on, right? I'm actually talking about a structure. It's a JSON structure of a document, which you can see on the right-hand side. So what you got on the left-hand side, and hopefully you can see this, so you've got two tables. You've got a table of people and a table of cars, and you may have, as a person, you can own multiple cars. That's fine. So the way you would represent this in the relational world is you're going to have two different tables, per people table, cars table, and you're going to have references. In this case, it's a one-to-many, so one person can have many cars. If you had a many-to-many situation, you may have to have a join table in between that that's going to go out each way to form that many-to-many relationship. In Mongo, because we can actually have all these different data types, such as you can have strings, numbers, you can have arrays, you can have sub-documents, I can model my data very differently. So what you have here, this is a single document within MongoDB, and if you look at at this field called cars, it's actually a list or an array of sub-documents. And every sub-document within this list is a representation of a different vehicle that Paul Miller happens to own in this case, right? So if I'm building an application, right, and let's say I want to build an app that shows me, I can quickly flap through maybe a bunch of people, and I can see which cars these people own. The advantage of this type of schema is that I have all my information in one document. Everything is grouped together, which means that as my application needs to access the collection of cars that Paul owns, I'm going to read this one document from my, from Mongo. I'm going to grab it back as an array or as a JSON document, and I'm going to have my application displayed to the user in whatever fancy form factor you want, right? I mean, this is where Express and Angular and Node comes in. You can do really fancy things once you have your data. Now, if you think how this same application would happen in the relational world, it would be quite different, right? You would have to go and first search your people's table, right? So I would find Paul. I would find a foreign key into that from the row where Paul is defined, and then I would have to use that to actually go into the cars table and scan. And if I have thousands and thousands of cars, the database will take some time to actually create this join and find the right, the right bits of information on disk. So it's very different. Kind of pre-aggregating, pre-joining the data to store in Mongo gives you a lot of capability, right, and a lot of performance when it comes to actually taking it out and displaying it as part of your application. And this is where the question of how are you going to use the data really comes in, right? Because if you tell me that your application actually doesn't care about showing Paul and his cars, and maybe your application wants it the other way around, maybe you want to see for every car, who are the, maybe it's an insurance application, right? And as a policy, you want to see for every vehicle insured, who are the people which are eligible to drive that vehicle. In that case, maybe your data structure or document structure needs to be different, where you have it modeled such that the car becomes your top element, and then people who are insured under that vehicle become in here. So you've got, maybe you have a field called people or insured, and you have the information about the persons, as a subarray of elements. So just to wrap it up, what we get with the document model versus relational is that A, it's very flexible, right? You've seen you can really easily change it around. So if you have a new requirement, somebody comes in and says, hey, version 1 of the application, we wanted to have it this way. Version 2 of the application, we actually need to change things around, right? I mean, this schema is no longer good. We want to actually do it from the other way, right? We want to go from cars to people rather than people to cars. You can do it real quickly, right? All you have to do, you're just going to change your application logic. You actually don't bother with defining the schemas within Mongo, right? The application changes, and Mongo reacts to that, which means it's agile, right? So these days, if you want to do anything real quick, you want to prototype things within maybe a couple weeks, a couple months, you want to be agile, you want to iterate real quickly, and Mongo allows you to do that, right? You don't have to rely on somebody else going in there, changing the schema for your relational database, right? Now, change the schema, go on, look at my relational, the ORM layer, the object relational mapping layer, change that part of code, go to my application, make the changes there. That takes a lot of time and effort just to be able to make those simple changes. So a lot of benefit by going with this type of, with a Mongo where it's completely flexible from a schema perspective. The other thing that is really cool is that it also provides better data locality. So I talked about in the relational schema, if you want to go in, you want to query, you want to do a join, which means that you're going to go and look at table number 1, and then you're going to follow the foreign keys into your other tables, and then you need to do the seeks on disk to find those bits of data to join them together to return the result of the query. That means that in the relational world, you're probably looking and you're looking at different sectors of your disk. That takes time to go and find those pieces of data. With Mongo, the data is actually stored together, so it becomes much more efficient. You just read a bunch of disk sectors, whether they were on spinning disk or SSDs, and you can just get it back so much faster than within relational. And we also do a lot of the in-memory caching. So the previous presentation, Kevin mentioned that Mongo does require a lot of RAM, and the reason for that is that the data is actually being cached in RAM, right? So again, if you are trying to build any kind of Web 2.0, almost like real-time application, like Twitter, for example, and your backend is relational, almost always you're going to have some sort of a in-memory caching layer, right? To be able to cache the information in memory and then serve it back to users, because the relational schema is just way too slow in terms of going back to disk and finding that data. So with Mongo, it's all in one place. You don't have to get other solutions, right? I mean, like, you don't have to bother with extensive setups and getting things to work together. It's kind of like all in one place. All right, so let me skip forward. I do want to get to the demo, and I want to make sure that we have enough time for questions. We have great support for drivers and ecosystems. So today we're obviously talking Mean. So there is support for Node.js driver and as part of the Mean stack, but there's also support for a number of other languages up there. So if any of you, have experience coding in something, other languages other than JavaScript and Node, or want to try things, then there's great support for things such as Python and Perl and C, PHP, and so on. All right, so let's get Mean now, right? A couple months ago, I've actually, I just got, I was very curious about Mean for a long time, and I was kind of brushing up here and there, trying to follow some talks. But a couple months ago, I've actually decided to sit down and write and code my application, get the full stack together, do something cool with it. And that's what I want to demo to you today, right? So the way I have it set up here is I've got this, 3 tiers, if you wish. You've got the client, which we talked about. Client is Angular. And you're going to see here on the side, Angular has this cool thing called directives. That's how you can bring in additional functionality into Angular. So if you want to do something like really fancy, and in my applications, I've got charts and graphs for dashboard view. I'm using this directives library, which is built on top of NVD3 and D3 JavaScript technologies, right? Some of you may have used it in the past. Server side, I've got my Node.js server with Express and Mongoose. How many of you have heard of Mongoose before? Okay, all right. So for those of you who have not, Mongoose is kind of like an ODM layer for Mongo, right? So it's a sort of an data abstraction layer that allows you to, that abstracts away some of the native driver features of Mongo, but it does incorporate additional functionality, and I'll talk about that. There are pros and cons to using Mongoose. It's not a requirement. You can actually use the Node.js driver directly with Mongo, but that is an option if you do want to have Mongoose as part of your stack. And now, from a developer perspective, right? So I think one of the previous tracks mentioned that when you're coding your client and server, these are actually 2 completely separate projects. The way I have it set up, and I'll talk about, I've used this boilerplate project where the client code is sitting inside, as part of my public folder, and the server code is part of my app folder. I actually have them in the same project, but this just happens to be the boilerplate template that I've picked. But you can have it completely separate, and the communication between the two is happening over REST API calls. So what's going on within my application? If we start from, you can see so if you start from the presentation layer, right? So the view, this is where I've got my Angular presentation layer. I've got these directives. This is what helps me to produce the fancy charts and graphs that you can see on the dashboard. So from my HTML view, I call to the controller. Again, this is all part of Angular, and the previous session we talked about how this all fits together. Because I now need to go back to my server and get some data from Mongo, I'm also using services, and service calls a REST API to a route which is defined inside Node. So Node defines these routes, which are just essentially URLs, and then at the end of the URL, I can append like a document ID or something like that, so that it tells my server-side logic in the controller and eventually the Mongoose model which part of the document I'm actually interested in, right? Or if I want the entire document, I can just pass it in the document ID. It's going to go to my Mongo database, retrieve that document as a JSON object, and pass it back to my front-end controller right here. All right, so there's 2 ways how I could go about this. I could use the native MongoDB driver. The way you would install the driver is with this npm install MongoDB. This just goes ahead, it downloads the driver, and it's pretty much ready to use. The native driver is very capable. It has a lot of the it gives you access to, I would say, almost all of the MongoDB features and functions that you could do otherwise from directly interacting with it from a shell. So you've got basic CRUD operations. You can connect to a Mongoose, which is a query router, and I'll talk about this in a second. That's a scenario where you want to scale out. You want to shard your data, partition your data. So we do have support for that. And using Mongoose as a query router completely abstracts it away from you as a developer. So as a developer, you really don't care if you have all your data sitting on one little box, like somewhere under your desk. Or if it's in the massive data center, which spans tens or hundreds of servers, right? It really abstracts it away from you. So this is a little snippet of code that that shows you how you would how you would connect to a database using the native MongoDB, the Node.js driver, and run some commands. So you can insert documents, you can update documents, you can query documents. And there is also, I'm not going to go through this, you're going to have access to all these slides, so you can look at it on your own time. And then aggregation is the way how you can actually then perform some joins and calculations on your data afterwards. So for example, if you wanted to retrieve the data and maybe, so I think the sample that I've got here has some authors with blog posts and comments. And if you want to, for example, aggregate the data to see, how many posts per author or how many comments per author per post you have, you can do this using this aggregation framework again. And MongoDB provides, full query language, full aggregation language that you can run, both via Mongoose and via the Node.js native driver, right? So we've got, you have all this full support via MongoDB driver. Now, if you wanted to go with Mongoose, there's a number of, reasons you may want to do that. It does add a little bit of complexity to your code. So for the simplest applications, I would probably just stick with Node.js driver. I don't see a reason to go to Mongoose for the simplest things, but it does do cool things such as validation of your code, pseudo joins. So I talked about that. Even though Mongo doesn't support native joins, so for example, if you've got two collections, maybe you've got a collection of people and collection of cars. We'll just stick with that example. Mongo doesn't give you a way to actually join this data to say, hey, for a given person in this collection, show me all the cars that this person has here, right? Question? I'm sorry? Yeah, you can definitely use a MapReduce. The aggregation framework, it's a much more simple way of doing some of those basic type of aggregations. Yeah. So the question in the back was about using MapReduce. You can definitely do that. It's a very advanced, it's much more capable JavaScript framework that allows you to, perform aggregations on your data. No. So it comes with the driver together. So when you do the npm install Mongoose, and actually, if you look at the files that it drops on your disk, you're going to see that it has folders for MongoDB driver. Right. So Mongoose will give you all the same capabilities that you have with the MongoJS driver. They might be a little bit behind, so as the driver gets updated, Mongoose may take a few months or so to get up to speed on the latest driver. But from my experience, they're pretty good and they're pretty up to speed. But if you want to do things such as validation, which is built in, the pseudo joins, rich query builder. So so if you're a little uncomfortable using the native query language that Mongo provides, it's all JSON based, by the way. You can actually use it with a query builder that Mongoose provides. And under the covers, it still calls the same Node.js API. So all you're doing is you're just using this extra abstraction layer. All right, so how do you get going with Mongoose? First of all, it's a node module, as you've seen before in the first big diagram. So what you want to do is you want to say var Mongoose require Mongoose, and it's going to bring in the module. You definitely have to do the npm install first, right? So make sure you don't forget to do that. Connect to MongoDB. You've got Mongoose connect, and then you have the connection string up there. It's prefixed with MongoDB : // and then it's a URL to your database. If you have a port number that the database is listening on, by default it's port number 27017, I think. If it's the default port, you don't need to specify it. If it's listening on a different port, you just put it in there as part of your URL. And then another thing that Mongoose allows you to do is it actually allows you to define your schema. So what you see here, so again, on the left-hand side, this is this is the structure of a document that I've used as part of the sample app that you're going to see in a second, and I'll talk about that in a minute. Now, what you see on the right-hand side, this is a schema representation that I've defined in Mongoose. And the reason you want to do that is that Mongoose needs to be aware of the schema and the models of your data that you're trying to write to the database. And this is how you can gain validations, pseudo joins, and all that kind of good stuff, right? So you do need to teach Mongoose a little bit about your data model, such that it can actually help you along the way. Because if you tell it nothing about your schemas and the models, well, it can't really do anything. And actually, you can't do anything with Mongoose unless you define a schema, right? Schema maps to a collection, and then from a schema, you will instantiate new objects. So right here, it will. I think, yeah, so, and then here at the bottom, where I have create the model object, so a model represents a document within MongoDB. So a schema represents a collection within Mongo, and a model, which is an instance of a schema in Mongoose, represents a document which is part of a collection inside Mongo. All right, and then same thing. So just as a very simple example, you can do all the basic CRUD operations. So you can do create, reads, update, deletes. You can do aggregations, and you can do all kinds of other fancy things. So in here's a very simple piece of code that I've got my service request. So if you look at this previous slide right here, var service request, it represents it is a model, so it represents a document inside my collection. And then in here, I'm actually calling service request.aggregate, and I'm giving it all this, MongoDB JSON type of syntax that actually tells Mongo what kind of aggregation I want to perform. So in this case, I think what it's doing, it is grouping data by date, by year, month, day. It's sorting it by service code request, and it's doing count. So you will see this, how it's actually being used when we go and look at the application dashboards. All right, so really quickly, I talked about the directives. I talked about the D3 JavaScript library. This is essentially what I'm using in my application. I've got the D3.js, which is a really cool, really powerful JavaScript library for graphs and charts. NVD3 builds on top of it. It makes it a little bit more easy to use, a little bit more consumable, so it creates those reusable chart components. And then I've got those AngularJS directives, which I'm embedding inside my client-side code, such that I can actually have it presented on the dashboard. And the way my code looks like, it's actually very, very simple, right? So instead of writing all this gigantic JavaScript code for D3 directly, I'm actually using these directives, which one of them looks like this, and it renders the full chart with all the data that I want to display as part of that chart. All right, so why don't we actually have a quick look at the demo app, and then I think we're still doing good on time. 10 minutes. All right, excellent. Okay, perfect. So this is a full stack application, right? I've used Mean, and I'll talk about actually the boilerplate because before I got going, I looked at a whole bunch of tutorials, and what I've noticed is that everyone was doing great things, but it was a little bit different. So if I watch a tutorial for Node and Express, they're suggesting doing things one way. Angular is slightly different. So I kind of had a little bit of a hard time putting things together. And then I'll talk about how you can go and you can actually find boilerplate templates that have everything pre-made for you in one place, so you can actually just focus on building your application code. For those of you who are familiar with Mean.io, how many of you have seen Mean.io? Okay, so you may notice that this is a template that they provide. It looks very similar to what you get, if you just go ahead and download the sample app from Mean.io. All right. Anyway, so here's the sample app that I did. It's so City of Toronto has this open data project where they provide access to all kinds of city data, right? So you can have data for service requests, for road repairs, for building permits, for traffic, highway, all kinds of data, right? And it's open there. So if any one of you want to go ahead and build an app that, for example, helps you to find a parking spot, you can actually use some of their open data and get really creative with that. So the app that I've built right here looks at service requests for the City of Toronto. And it allows you, so for example, if you notice a pothole in the middle of the street, if you see graffiti, if you see some garbage, you can actually go in and you can open up a new service request. Now, this data, this is just my local machine. It doesn't actually get into Toronto. So don't use that. But if you call like 311 service or something, you can open up a new request, and then the data will actually come down here because I have this web service API that I'm calling. So as new requests come into the City of Toronto, they will get downloaded and populated into my dashboard right here. So anyway, so what I've got here, you can go ahead and you can look at the last 10 service requests. This is a query that is being sent to Mongo, and all I'm saying is, hey, show me the last 10 requests that came in. If you click on any one of these requests, then what it's doing, and if you look at the URL, it is actually calling one of my REST API on the server side, and it's passing this object ID as the last parameter. So again, it's telling Mongo which document it needs to retrieve from a database. I take this document, I can now display it here on the web page. Same way, I can go and I can create a new service request. So for example, if we've been having a lot of bad roads, so if there's a pothole in the middle of the street, you can put in a location. So I'm going to say, I don't know, 115 St. George, near UFT, pothole in the middle. All right, so now, and as you hit the submit button, what it's actually doing is that it's creating a new service request object with Mongoose, right? And as I hit the submit button, it's actually saving that object to the database, right? And Mongoose handles it all for me. So again, because I've got here Angular on the front end, it does this whole round trip where it goes to the server side, it calls up the Node application. Within Node, I've got my Mongoose schemas and models. It creates a new model which represents this particular service request, and then as I hit the submit button, it actually invokes the save method of my model to write the information to the database. So now if I come back here and if I look at my service request, you're going to notice here that, hey, here's the one that I just put in. It's in the database. I can go back and I can read it out. So it is the same location that we've just put in, right? So it is pretty simple. Now, the cool part that I kind of wanted to put together is this visual dashboard. And again, what's happening is that I've used these directives where I've got all this data, which is now being driven from Mongo. I retrieve it, I bring it here, I run the aggregations. So every chart behind the scenes is running a query, a Mongoose query, which retrieves the data, runs a certain aggregation command, and then passes it back to my library right here. So what I've got this chart that I can look at service requests that came in by day. For some reason there was a spike here on January 13th. So if I'm a clerk at the city of Toronto and I need to watch these things, it gives me some indication of what is really happening with our city data. I've got 2 requests that I've just created myself here on the 29th, which is today. Right? You've got all these other kind of cool charts where it's a stacked graph. It shows you the breakdown of requests by request code. So I've got 6 different types of requests, right? For graffiti, for garbage, for potholes, whatever it is. And I can really, now in a very interactive fashion, play around with my charts. The data is all cached, on the front end. So once I do the query, I retrieve my data, I bring it to the front end, and now it's all sitting within Angular. So I can now slice and dice it right within this, front end. So it doesn't actually do a round trip back to the server side. All kinds of really cool stuff for grouping data by month, by state, so I can see how many requests are open versus closed requests, and then same thing here. This is a breakdown by request type. So, for instance, if I wanted to, maybe turn some of these things off, it is really cool. It is really snappy. So it does, it does run the aggregation based on the controls that I'm selecting here on the front end. So that's, that is really the bulk of the application that I've built. Again, it goes through the full mean stack. It uses Mongoose, it uses Angular, it uses Node, Mongo, kind of the full 4 major components within the stack. All right. So what I do, yes, 5 minutes. All right. A few more things that I do want to mention. If you want to get a few more things that if you want to get going with Mean real quick, what I found to be really useful is either you can go to mean.io and you can download a full stack boilerplate. So they give you, so essentially they've set up this project, they've pre-configured things for you. It's a simple blog type of app. You can get rid of their blog business logic, and you can put in, you can put your business logic in there. So it's a real quick way for you to get going. Another one, and there are some good generators out there, right? So how many of you have heard of Yeoman as a generator tool? Okay, so it's quite popular. And again, so this is something that you can use right there. You just install the Yeoman as a generator, and there is some community mean stack generators out there. I've tried all three of them. You know, they all work. They're all cool. They do things a little bit differently, right? So the file structure, the project structure that you're going to end up with if you run one of those three is going to be slightly different, and it's really your personal preference towards, you know, which one you like better. You know, after spending maybe a couple hours playing with this stuff, I went back and I downloaded the meme.io because I felt this was kind of really clear and really structured. But there is nothing wrong with those other three. You can, you know, get going in a matter of minutes with one of those three. All right, so we only have a few more minutes, and I do want to mention a few other, you know, capabilities of Mongo. So let's say you build this app, right? I mean, it's being a little proof of concept. You know, you had it running for a couple months, or maybe for a year, and let's say it really takes off, right? I mean, everyone in the city of Toronto wants to use your app. Everyone wants to go on. You know, they want to look at service requests. They want to open up new service requests, right? And at that point, what happens is that now you actually have to, you know, go back and evaluate, like, do I have enough hardware, right? Do I have enough RAM? Do I have enough CPU? You know, what is my actual deployment architecture looks like? And this is where Mongo, again, it really shines in a way that it allows you to shard your data or partition your data. You know, it makes it very much abstracted away from you, right? There is a little bit of work involved that will help you to take a single node of, you know, a single database node from Mongo and say, hey, I want to split it into 3 different chunks. We call them shards. And essentially now, instead of having just, you know, like one bulky box that is serving 10 million users, you can have, you know, 3, 4, 10, you know, 50 different boxes, smaller size boxes, cheaper boxes because they don't need as much RAM, they don't need as much CPU power, but still the solution that you deliver to the end consumer, you know, is super responsive, it's highly scalable, it's real snappy, right? And so the performance is great. And the cool thing about this is that there is really maybe 2 lines of code that you need to change in your driver logic to say, hey, I'm actually talking to a sharded collection versus I'm talking to a single node. So you don't need to change your application logic at all, just the way it connects, you know, just the way the driver connects to the database. And the other thing is we didn't talk about is the high availability, right? At some point when your application becomes, you know, really popular and everyone wants to use it, it is kind of important that it's, you know, it's also highly available. You don't want to be in a situation where this thing just goes down in the middle of the night, nobody knows it, you know, or you get a wake-up call in the middle of the night saying, hey, this thing sucks because it, you know, I just lost half of my data. So this is where, again, built-in support for replica sets. And what that allows you to do is you can define a replica set. Every node within a replica set has the exact same data. So, you know, so it's actually replicating data in between. You've got a primary node. This is where your application is supposed to read and write data from. And you've got secondary nodes where, you know, you've got the replication going in the meantime. So if your primary node goes down for some reason, one of the secondary nodes will actually come online instantaneously. It all happens magically behind the scenes. You actually don't need to be involved. The replica set knows how to elect a new primary in case the old primary goes down. So if that does happen, you know, you wake up in the morning, you go check the log files, whatever it is, you repair the old primary, you put it, once it's all good and it, you know, and it's fixed, you put it back into the replica set, and the old primary will know how to catch up with, you know, with the new data that was, you know, that was written to that replica set, right? So really, really hands off for you. You don't have to be involved in the middle of the night, just, you know, kind of after the fact. And with 0 minutes to go, this is the overall architecture. I think I talked about all of this, so, you know, we kind of dissected it bits and pieces at a time. All right, thank you. For any questions, I think we are 1 minute. One question if there's anything. Yes? Right. Right. Yeah. Yeah. Absolutely. So there's a couple things. One thing I'm going to mention is you definitely want to have indexes. You want to create indices on the right attributes that you can later query your data on those indices. You want to make sure that the indices that you create fit into RAM. For example, if you've got a document that has a nested array with 1 million items in that array, and you decide to create an index on that array, which you can, by the way, right? That is going to create a massive, massive amount of an index of a massive size that may actually not be able to fit into your working RAM, and that's going to create bottlenecks, for example, right? So you want to be careful which fields you choose to index based on how much RAM and resources you have. The other one that I can mention real quickly, if you go into a sharded environment, right, where you've got data living on different, chunks of data living on different shards, you want to make sure that your aggregation and query can really zoom in on a single shard as much as possible. Because if you don't do that, what happens is that you send your aggregation or your query, and if you don't tell it which shard I'm looking at, it really needs to go through all the shards and do all this massive computation, where the data you're looking for may only be on shard number 2. So it's things like that. All right, thank you.